Okay, these are our 1-1 notes on undefined and basic geometry terms. So these undefined terms are the basic building blocks of geometry. And our first definition is for point. So a point is just going to be defined as just a location. And we use just a capital A letter to represent it and call it point A. A line is a one-dimensional collection of points that extends in one direction, like back and forth. And we can use a small lowercase letter to represent the line, or we use 2 points that are on the line. So we could call this line AB. We could call it AB with the line symbol above it, and also that could be called something like line L. A plane is a flat surface composed of points and lines, and we name a plane with a capital letter, so that we would call that plane M. A line segment is part of a line. It has two endpoints, so the piece of the line that goes between A and B we call a segment. We could call it segment AB, AB with the segment mark above it, or segment BA, because the order doesn't matter. If we have a ray starts at a endpoint and goes through another point on the line, like a direction indicator. So we have ray AB with the ray symbol above it. We could write it out, and the order matters on rays. The first letter is always the starting point, and the second letter is the direction indicator, and the ray symbol above always goes to the right. A postulate is something that's taken to be true without being able to prove it, like parallel lines never intersect. Space is a three-dimensional idea. It's an infinite set of planes, and we could represent this by like the inside volume of a box or a rectangular prism. Collinear are points that are all on the same line. Co means together, linear means on the line. Coplanar, all in the same plane or on the same plane. So in the plane, B, D, E, and F would all be coplanar. H would be non-coplanar with the others. And on the collinear, A, B, and C would all be collinear. And two lines can cross each other, and we call that the intersection point. And we could label that K. And the intersection of two planes is going to be a line. So two lines intersect in a point. Two planes are going to intersect in a line. So we can kind of draw the edges of a box, like the ceiling and the wall, and that intersection is actually a line. Looking at the other side, the B side here, when we're measuring segments, you can actually just kind of count on the number line. The distance from S to T is, how far it is between S and T. We use ST without any marks above it. It's always going to be positive because it's distance. And on the number line, we can just actually count. So ST is, and we're counting by twos, which is the scale. So we count by twos, we find out that the distance from S to T is 12. The distance from U to V, do the same thing. And another way to find SV is to think about how far one is on one side of 0 and the other, and then add those together. So SV is 18, and we found out that UV was 4. For number 5, 5.7 take away 5.8 take away 3.7 is 2.1. And for number 6, we add those together, we get 5.3 for the distance. For the last one, 59 is the total distance, so we combine like terms. We have 12x minus 13 equals 59. Add 13 to both sides. 12x is 72, and x is going to be 6. It wants to know what the distance from E to F and F to G are, though. So 8 times 6 take away 14 is 34. And 4 times 6 plus 1 comes out to be 25. And that checks out. Next page, what are JK and KL? Well, together they make 120, so we have 11 x's plus 21 makes 120. Take 21 away from both sides, we end up with 11 x's is 99, so we get x is going to be equal to 9. and we plug it in. 4 times 9 take away 6 is going to be 30, and 7 times 9 plus 15 is going to be 63 plus 15, which is 48. So we get 42 and 78 rather. For these segment lengths, we can just actually count. We find out that AC is 7 and BD is 7. So yes, segment AC is congruent to segment BD. For these other two, we find out that the distance from A to B is 5 and the distance from C to D is 4. So they are not congruent to each other. So D to E is not congruent to AB. And here, these two segments are equal to each other, so we can set the algebra equal to each other. 6x plus 20 equals 2x plus 12 when we use the distributive property. Take away 2x from both sides, take away 20 from both sides. We get x is equal to -2, and that's all we needed to find.